Hello friends, welcome back to the channel. Hope everyone is doing good. I'm back with another small project. So this is a water tank automation. So basically, my situation at home is we had a water tank in third floor, and there is a motor which fills water into the tank at ground floor. So every day morning, my mother will turn on the motor, and there is no way of knowing the water level at the tank. So she'll just turn on the motor, fill, and if the water overflows in the tank, that water comes into the kitchen sink. So my mother has to pay attention to the sink and see like if there is any water overflowing from the tank. If the water started overflowing, then she will turn off the motor and stop filling the tank. So this whole process is manual today. So I want to automate this. Now there are like lot of systems in the market available for this. The problem with those systems is we need to have a direct path between tank and motor, or at least some sort of conjugate or plastic pipe that connects motor or a motor and tank. So there will be some wires that goes into motor and some wires that goes into tank. So there is lot of wide communication between sensor and as well as a motor and tank. So I want to avoid this. So in this video, like I'm mainly concentrating on Wi-Fi. So both the tank as well as motor is under same Wi-Fi network. So I mean they're in the Wi-Fi range. So I'm thinking of having one controller at tank side and another controller at motor side, which communicates with each other and able to turn on and turn off the motor. So yeah, let's go to the component list. So the first component is the microcontroller. So we are going with the ESP01S. Remember, we are using S version. I'm not going to write some sort of code in these ESP01 controllers. I'm going to install ESP home firmware in these controllers. So I need more flash memory. So S version will have about 1 MB of flash memory, while non-S version will have 512 KB. I think non-S version will also work with the ESP home. But I'm not sure. More aligned to use more flash memory. So ESP01S is the right choice for me. And the second component is this particular relay module. So this relay module, basically what it will do is your ESP01S will directly go into this yellow connector, and you can these green connectors are basically your 5 volts and the relay output. So if you supply your 5 volts to this module, basically it works as a Wi-Fi switch. So basically you can control this switch using Wi-Fi. And there is the power supply. Now we have seen the 5 volts, right? So, but the problem is we don't directly get the 5 volts from the AC. So we need to convert AC to DC. So this particular high-link module will take AC input and converts it into 5 volts DC. You need two of these, both ESP01S you need two, and this particular power SMPS you need two. Okay, so and coming to the relay module, you only need one because you're only controlling one switch. Tank side, you will have three components. One is this power supply, and then there is this ESP01S, which is your brain, which will tell the switch to turn on and turn off. And you need a sensor which tells the ESP01S water level. We are using a float switch. There won't be any battery or any sensing unit in this. It's more like mechanical. So when this particular float switch is completely vertically hanging, that means there is no water in the tank. Then the wires, they basically there are three wires. We only concentrate on two wires. So those two wires will come into contact when this is vertical. Those two wires will get into contact. And if let's say the water is till the top of the tank and this particular float switch is not hanging, in that case, that the two wires will disconnected. So basically, this is a binary switch that tells you whether tank is full or not. That's it. Float sensor will connect to your ESP01S, and that is powered by your Hilux module. So that is at the tank side, and at the switch side, you will have the relay module and then ESP01S as well as Hilux SMPS. Yeah, so this particular 3D print solution, so he is using a small do-it-yourself PCB and basically connecting everything and like making a small son-of type module where you will have your controller and then relay and power supply, everything in a small box. And he is giving us the terminals for everything. So to basically you can close this and this will go behind your switchboard so and controls your switch so very nice solution. So I have so other components are basically the connectors, these PCB connectors, so and also like headers and all. uh, I'm not going through those components, so you can just look into them like. And the another important component is your this programmer. So without this programmer, you can't program the ESP01S because the ESP01S doesn't have any micro USB B or C to it. So you need this programmer, and your ESP01S will go into these yellow headers. So that's how you program your ESP01S. There is a small modification you need to do for this. Okay, so this is the controller I have here. Okay, so for this controller, if you see the back, you need to attach a small push button. So whenever you are putting your ESP01S into this particular yellow pins, let me do that. So to make it a flasher or programmer, you need to click this push button and then insert into your mission. And then only this will act as a flasher, or else it won't act as a flasher. It basically just a USB to UART system. So if you observe carefully what pins I have shouldered, I'm bringing this closer. There is nothing much here. You just need to shoulder two pins. This is a 6 mm into 6 mm push button. So for this, I had a 3D printing case too available. So if you can just this. Yeah. So this is a cute case I have printed for this particular programmer. The link for the 3D printing case as well as the sheet too. So I will also link the sheet in the description too. So you will have order link and everything in one place. And the overall cost is yeah. So the overall cost is around 1200 INR. So that's it for this video. In the next video, we will see how to set up ESP home in both the Node MCUs and also write some configuration to control the motor using the float sensor. Thank you guys. Please subscribe to the channel.